Okay, so on this lesson, we're going to be continuing to look at transformations, but we're going to look at composite transformations, which means you have two or more transformations performed on one graph. So that's what a composite transformation is. So a composite transformation occurs when two or more transformations are performed on your graph to produce the new function. So we're going to continue to look at your square root, your cubic, and your cube root. Your process, you're always looking for a reflection based on these two things: vertical and horizontal stretch or compression, and vertical horizontal translation, which is your shift. Okay, so first thing we're going to do is we're given the parent function, and then we're given a new function. We're going to use our understanding of transformations to graph that new function. Then we can talk about the function notation. So first thing, compare your parent function to your new function. Notice the inside of the parentheses, which we will have to adjust our x. Remember, the inside's always the opposite, so it looks like we have a shrink or a compression because it's a 1/2, but it's the opposite. So we would have a horizontal stretch by 2. And then we have a +1 on the outside. That's always vertical, so that means it's going up 1. So remember, the inside's always the opposite. Okay, so first thing, I'm going to go ahead on this one. I'm going to go ahead and graph what my parent function looks like. So I know 0, 0 was one of them, -1, -1, -2, we cube it, we get -8. And then 1, 1, 2, 8. So this is what our f function looks like, which is our parent function. Now we're going to take our 0, 0 point and we're going to shift it based on our transformations. We're going to go up 1 with it. So go ahead and plot the 0, 0, the new 0, 0 point. And then we're going to have to adjust our x based on this stretch. So whatever the stretch is, that's what you're multiplying your x by. So we're multiplying our original x's by a 2. So instead of a point being 1, 1, it's going to be 2, 1. So I go right 2 from my new 0, 0 point up 1. Instead of being 2, 8, it's going to be 4 because we're having to multiply it by 2. And then 8. And then same thing on the other side. So left 2, down 1, and 1, 2, 3, 4. So there's my new function g. So make sure you're labeling it if you are going to graph your parent function. You don't have to, but if you want to, then you can. So we're going to write the function notation description. So f, instead of just putting an x, we know we have to put 1/2 x in parentheses and then the +1. So that tells me that there's a horizontal stretch by 2 and then up 1. All right, so again, you can graph your parent function. You don't have to, but you need to know what those original points are. So you might want to learn those. So in the next part, we're given cube root of x, and then let's go ahead and write our transformations based on our new function. So there's a negative on the outside, which is a reflection over the x-axis. The -1 on the inside is always the opposite, so that's going right 1, and then the -3 on the outside is going down 3. So again, if it helps you, you might want to graph your parent function and then your new function. So cube root of x, 0, 0 is a point. If you remember, we plugged in an 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then we got 2. We plugged in a 1 and we got 1. And then same thing on the other side. So it will be very helpful if you know your parent functions. Or you can just pick some points, plug it into that. Okay, so based on our transformations, we're going to graph the new one. So we're going to have to, let's go ahead and shift the 0, 0. So you always want to shift the 0, 0 if possible, and then you can look at your stretch, compression, or your reflection. So I'm going to be going right 1 with it and down 3. I'm not stretching or compressing, which means I don't have to multiply my x's or y's by anything. But when there's a reflection about the x-axis, that means you're going to be changing the sign of the y value. So instead of our points being 1, 1, it's going to be 1, negative 1. So go right 1 from your new 0, 0 point, down 1, left 1, up 1, and there's your new G. So I want you to plot at least 3 points on these. So you need at least 3 points. Also, a great way to check your graph is a negative sign in front. Means it should be decreasing from left to right, and notice it is. So your function notation, we have a negative on the outside. We have f, which is our original function. We're going right 1, so in parentheses we need x minus 1, and then the down 3 minus 3. So that's your function notation description. Okay, so part C. Square root of x. If you want, you can go ahead and graph that one if you want. So plugging in a 0, you get 0. Plugging in, we can't plug in negatives. We can't take the square root of negative. We can take the cube root of negative, but not square root. So our points were plugging in a 1. Square root of 1 is 1, 4, 2. And so remember, your square root parent function is a ray. So it has an endpoint, and then it's continuous the opposite direction. Okay, so let's look at our transformations here. So the 3 on the outside means you have a vertical stretch by 3. And then inside is always the opposite. It says plus 2, so you're going to be going to the left 2. So those are our transformations from our parent function f. So go ahead and shift your 0, 0 point. Go left 2 with it. Plot the new one. And then my vertical stretch by 3 means we're going to be changing the y by 3. So instead of having a point of 1, 1, it's going to be 1, 3. And then instead of having a point 4, 2, it's going to be 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. Oops. So there's my function G. So writing your function notation, we have a 3 on the outside, we have f, and then inside we have x plus 2. Okay, so it's very important that you know what your parent function looks like, so that way you can use your transformations to graph the new one. Let's look at the back. So now we're going to be doing the opposite. This time we're given both graphs, and we're going to write our verbal description, our function notation, and then come up with the actual equation that we were given on the front. So the f is always your original, and then your g is your new function. So looking at it, you have to know what this graph looks like to know what type of equation you'll have. So this back one, or this part A, is going to be a cube root So verbal description, notice my 0, 0 point went down 1, 2, 3, 4. So it went down 4. And then it went left 2. Notice my point 1, 1 is still there. So that's good. There's no stretch or reflection based on that. So now we're going to use that to write our function notation. So f parentheses, we're going left 2. So in parentheses, it should be x plus 2. And then down 4 would be minus 4 on the outside. And then this is the part where you had to know that it was a cube root. So we're going to have a cube root, x plus 2 on the inside minus 4. Okay, let's look at another one. So looking at this one, f is your parent function. This is a square root graph. So notice our 0, 0 point did not change. It's still there if you look at G. So it didn't shift left or right. I do notice that it was reflected over the x-axis. And then I also noticed that it has been stretched. So look at your 0, 0 point. Normally it's 1, 1. So from 0, 0, it went 1 and then down 1, 2, 3. So the down is the reflection part, and then at 3, so that means it was a vertical stretch by 3. Okay, so our function description, we have a 3 on the outside, and then we have f of x, and then the reflection across the x-axis makes the front of it negative. So a reflection over the y-axis makes the inside negative. So your equation for G, we know we have a square root, so negative 3 square root of x would be your new equation. All right, let's take a look at the next one. So looking at your f function, here's our original. This is a cubic. Notice my 0, 0 point shifted 1, 2 to the right. It didn't shift up and down. I also noticed that it's decreasing from left to right, which means there was a reflection over the x-axis. And then check your points. Normally there's a 1, 1 point, so right 1, and then it goes down 1, which is the reflection. So there's no stretch or compression. So your function notation would be the negative on the outside because of the reflection, f of x, and then it goes right, my bad. It goes right 2, so on the inside you should have a minus 2. So writing your equation, we would have negative, it's cubic, so in parentheses we need x minus 2, but on the outside we need that cubed. Okay, now let's take a look at the next part. So now we're going to be given the parent function, we're going to be given some transformations, we're coming up with our new equation G. So we're starting, always look at what you're starting with. We're starting with x cubed. It's reflected about the x-axis, so that will put a negative in front. It's vertically compressed by 3/4, so that's on the outside, and translated right 10. So in parentheses we need x minus 10 and then cubed. So there's our new equation. Part B, we're starting with square root of x. It's reflected about the y-axis, which changes the sign on the inside. So we'll have negative x, and then it's vertically stretching by 5/2, so that goes on the outside, and translated up 15. So on the outside of the square root, we need plus 15. All right, part C, we have a cube root of x. It's vertically compressed by 1/3. That goes on the outside. Draw your cube root of x. Right 18 means we're subtracting 18 under the cube root. All right, try D, E, and F. So press pause, do those 3, and then I will write the answers down. So part D, you should have got x in parentheses plus 5 cubed and then minus 9. Part E, you should have got negative on the outside and then a cube root of 1/4 x, because remember horizontally it's always the opposite. Instead of 4, you're going to put 1/4. And then F, you should have got square root of 2, because it's horizontally compressed by 1/2, it's the opposite. And then left 8, make sure you put this in parentheses, so x plus 8. All right, if you have any questions on composite transformations, please let me know.